thing we're going to do today, we're just going to change it slightly. All right? So, first thing we're going to do is we're going to start with what we know. So, let's start with, that's recording, good. Y equals 2x plus 5. Okay, so you've all seen that before, yes? It looks like something we had in grade 9. So tell me everything you know, anything you can think of about that equation. What can you tell me about it? Nobody can tell me anything about that equation? Oh, guys, come on. I know it's first block, but let's go. Oh, Carlin.
To get y, you have to go 2 times x and then
Okay, so Carlin can put it into words. To get y, you've got to double x and add 5. Excellent. Okay, that's something he knows about it. Okay, why did you say it that way? Why did we have to double x and add 5 to get y? Why did you put it in those words? Okay, that's fine.
I know what I mean, but I don't know.
Okay. Can any what is Carlin saying? To get y, I have to do something to x. So where do you start? How would you start telling me some y's? Because this equation says I'm going to equal y. How would you tell me some y's? Emma. Okay, but I have no chart. I only have that. Make a chart. Okay, now we're talking. Okay, I see that. I want to make a chart. Excellent. Okay, so we make a chart. So everybody knows we can make a chart from here. I hope everybody knows that. Great. Okay, then what? Emma says take the first number. It's blank. Choose numbers. Excellent. Where do I put those numbers? On the x side. Why do I put them on the x side? Excuse me for using WHY and the letter Y, right? But why can I put numbers here? Independent variable. And do we have another name for it? Input. Excellent. So we know this is a function, right? Or relation, I mean, because something that happens to x is giving me y. It might be a function. We also know that we have an input, and that's the x's, right? So here we have input. What's this, then? Our dependent variable, because it depends on what happens over here. What is happening over here? Carlin already said it. We're doubling x and adding 5. So our dependent variable depends on that. And our dependent variable has another name. It's our output. So is everybody good with that? Right? We all know how to work this out. Now, who chooses the x's that we put in? You do. Why? I know, right? It's bothersome. It's a pain. But why do you choose it? I'm not sure what we do with that. That didn't sound very sneezy to me. She said the letter Q. So what numbers can I put there? Anything I want. Why is it anything I want? Because it's the independent variable, right? We're going to do stuff to it to get the output or the dependent variable. So does it matter what letters I put in there? Or what numbers I put in there? No, not at all. How many numbers do I need to put in there if I want to make sure it's a linear function or relation?
3.
I need 3, right? And I need to do something special with those 3. What do I have to make sure on this side? So give me any 3 numbers. Or give me 3 numbers that would be good choices for here. -1, 0, and 1. Why, Emma? Wait, Emma, for what reason did you choose -1, 0, and 1. See what I did there? I didn't even use that word. They're in order, and they follow the first part of what we need to be linear, right? Their change is the same, right? Okay, so if we put -1 there, what do I get in the y? Use your calculator if you need to. There's no shame. 3. For what reason is it that I get 3? How did Jasreet know that I can write 3 there, where the red dot is?
Multiply 2x, 2 times -1.
She really did 2 times -1 plus 5, didn't she? Right? And then what would she do for 0? 2 times 0 plus 5, which is 5. And what would she do for 1? 2 times 1 plus 5, which is 7. So 3, 5, 7. Is this a linear relation? Yes, because I went up by 2 every time. Everybody knows how to do that from the 9th grade, yes? You put your x value in, you get your y value out, right? Every one of you can do that, yeah? Okay, so now, right here, I want you to write y equals output. And then we're going to write our new thing. And I'm just going to wait a moment so the computer is unfrozen and it comes out as I write it.
Could we talk about the pep rally really quickly?
Yeah, knock yourself out.
Okay.
So anyway, where was I? What was I saying? Oh, right. So now we're going to write the new thing. We all are cool with y equaling our output, yes? Okay. Well, it also equals something else. And what it equals is function notation. And what function notation looks like is this. f(x). Some of you have probably seen that in the 9th grade or in your textbook. And I didn't wait long enough because it froze anyway. There we go. That's what it looks like. Okay? This is red. You read that this as f of x. That's what you say. Now, the f is the function's name. Like that kid that just walked in is Daniel. He has a name to differentiate him from that kid sitting there in the red hoodie who's Jordan. Do you all understand? I'll get to that. Okay. If I need to speak to the other Daniel in the class, I could differentiate him further by going back to his name. I would say Daniel Core. Is everybody cool? That's all that f is. It's to tell you what the particular function that you are dealing with, which one you have. So, for example, if I gave you this guy and another function, and I wrote the second function, I'm going to write that second function in red down here, y equals 3x minus 1, and I told you, what's the output when x is 0? How would you know which of these to use? Would you? I've given you two functions. There they are. There's function 1. There's function 2. What's the output when x is 0? Can you do it? How? Okay, for which one? But I didn't ask for both. I want the output when x is 0. So can you do it? Why not? Because you don't know which one I am speaking of, right? So in math, what we do is this. We take this problem right here, and we write it this way. F of x equals 2x plus 5, and then – 2 g of x equals 3x minus 1. Now they have two different names, and now you know which one it is that you are working with. Is everybody cool? All right. Now let's put this into action. Notice this first one here. This guy is written the way we already know. Yes? Right? He's written out exactly how we're used to seeing it. So y is output, x is input. We've been given we have 4 inputs right now. Yes, it's 4, right? Everyone agree? So what do we do with those inputs? We substitute. You can just write sub. You don't have to write it all out. We substitute each input for x to get 4 outputs. Everybody's cool with that, yes? Now, do you have to use your calculator for this? Maybe, maybe not. I don't know. That's up to you. But you do know that this -2 has to go there for x, yes? So what's half of -2? -1. What's -1 minus 2 more? -3. Is everybody cool with that? Now, if you're not totally sure about why that happened, I'm going to write it right here. 1/2 times -2 minus 2. It'll show up in a sec. The x became -2. So what is the x going to become in the second row? 0. What's 0 minus 2? -2. 1. What's 1/2 times 1? It's not a trick question. 1/2. Take away 2. -1.5. And what's half of 4? Take away 2. 0. Is everybody cool? Everybody could fill that in, right? Now, talk to me. Is that a linear relation? It doesn't look like it. Why? How far did I go up there? +2, then what? +1, then what? +3. So it doesn't look like a linear relation, but I gave you a little trick, didn't I? Looking just at the equation. Is that a linear equation? I call your attention back to there. Is that a linear equation? Yes. Why? No exponents. And indeed, if we checked, it would work. Because see, when we went up by 2, we went up by 1, right? Right? So that means if we go up by 1, we should go up by 1/2. Did we? Yep. And then when we go up by 4, we should go up by 2, right? Did we? So it is linear. Is everybody cool with number 1 there? Yeah? Everyone can do everything I did on number 1, right? Okay. Now look at number 2 and use what you already know, what you learned today, to figure this out. Here is a function, right? He's got a name, it's function f. this in blue shares some characteristics with what is highlighted right above in yellow, right? I just can't slide up to it because my computer's frozen. What are the characteristics the blue guy and the yellow guy share? They have an input and an output. Okay. What else? Are they both linear? Yeah. Do they both have an x? Okay. Do we know what to do with x? What do we do with x? What do we do with this yellow one and the chart? We fill in the table, right? Now, what if the table looked like this? What do we do then when there's no x's? We put our own numbers in, don't we? Because the x's are what?
Equal to what?
No. Sometimes.
Not very strong in math, ever. I have a deal for you. I think you have a toaster in this room, and I'll trade you a toaster for a lazy bed when it's ready.
Yeah. It's a high-end toaster. It's a Krups. I got it for my wedding in 1999.
I have stuff from my wedding too that haven't broke yet.
Yeah.
You don't want me with muffin with it.
Thanks. What was I saying? Where were we? All right, what do we do with x here? We plug our own values in, don't we? Right? Okay, now specifically look at that and look at that. What is the difference between the two things with boxes around them? One has a 2, one has an x. So the f of x is 2x minus 7. This says the f of 2. What has x become? 2. So what do you think we do? We put 2 in for x. That's it. And kids find this difficult. So the f of x is 2x minus 7. I don't want the f of x though, do I? What do I want? The f of 2. So what is that? What would I write instead of 2x minus 7? Not just an answer, please. What would the whole thing be? 2 times 2 minus 7, which would be what? Negative 3. Is everybody cool? Can everybody do that math? Everybody understands? Okay, now, what is the ordered pair that gives me? Which is the x, which is the y? 2 is the x, because it says f of 2 is x, and what's the y? Negative 3. So, everything we know about these 2 points, we know that that one's x, that one's y. We know that that one's an input, that one's an output. We know that is a domain value, that is a range value. And we also know that this is an independent variable value and this is a dependent variable value. And we also know that if we had a chart, it would be 2, negative 3. Does everybody understand that? Everybody's good? Great. So what's the next one? I don't want the f of x. What do I want now? The f of negative 3. So what do I write? I write the f of negative 3, and instead of 2x plus 7, what do I write? Which is what? Negative 13. What's my ordered pair there? Can everybody do this? It's pretty easy, right? The question tells you what to do. The only thing that's different is instead of y, we've written f of x. That's the same as a y. Is everybody cool? So, knowing that f of x is the same as y, can we write our tables of values differently? What would it look like now? It's not going to be x and y. It's going to be x and f of x. Everybody cool? Okay, let's see if indeed you are cool. Go on to number 3 and see if you can figure it out. Actually, let's do 3 together, and then we'll see if you guys can do 4. So, I have a function here. Mr. Mars, why'd you give us ones with fractions? Because you're smart kids. So, there's my g of x. If I'm going to graph it, I need a table of values, don't I? In grade 9, that table of values was x and y, right? What is it now? X, f of x, g of x. This function has a different name. So, do I have some input values? What are they? 6, negative 3, and so I need to do the g of 6. What does x become? 6. So what does that x become? 6. Negative 2/3 times 6 plus 1. You need to know how to do that. What is it? Don't yell it out if you're one of the 5 people that know it automatically, because there should be a few of you. How do I do that? If you need help remembering, that's what it really means. And in multiplying, the easiest way I find to do it is to cancel everywhere you can. So because 3 goes into 3 once and goes into 6 twice, I can cancel it. Negative 2 times 2 is negative 4. Everybody cool? So I have negative 4 plus 1, which is negative 3. So if my g of 6 is negative 3, what number do I put right there? Negative 3. Everybody cool? Let's do the next one. I need the g of negative 3. Negative 2/3 times what? Negative 3 plus 1. What do you do with the 3's? Because that's really 3 over 1. What do you do with the 3's? Cancel. 2 negatives makes a positive. So that's positive 2 plus 1, which is what? 3. If the g of negative 3 is 3, what number goes there? 3. And then we need to do the g of 0, which is, of course, super easy. G of 0 is negative 2/3 times 0 plus 1, which is what? 1. So what number goes there? 1. Do I now have my 3 ordered pairs? Can I put them on a graph? Can I put them on a graph? Great. What's the first point? 1, 2, 3, 4, 5, 6. 1, 2, 3. Agreed? Second point. Negative 3. 1, 2, 3. Up 1, 2, 3. Third point. 0, up 1. Now, do I have 3 dots? Do I connect them? Is this continuous data? You got to ask yourself, can I put every single number in there for x, including decimals and fractions? I can, can't I? Because I can take any number, multiply it by negative 2/3, and add 1, can't I? So I would connect the data. It's a crappy line, but you know what I'm saying, right? Everybody cool? Now, what if you did this graph and you screwed up somehow and had a dot up there? Would you hand it to me? No, of course not. Why? Because it has to be linear, doesn't it? Because there's no exponents. Everybody good? So 0, 1, there. Ooh, that one was better. Cool? Okay. Now, look at what we know. What function are we using? We're using the g of x function still, aren't we? But something's different. What is different here than son of a motherless? Than here, I didn't want that to be green, than here, here, and here. How does that green one differ from here while I eat my fake eggs Benedict?
Oh, the lazy Benny.
A lazy Benny. And if you haven't taken Miss Brar's cooking class and you are planning on going out and living on your own, you should. Because this is delicious and it's easy to make, but you have to, enjoy ham, cheese, and egg. If you don't like those things, you don't want to make this. Connor, go to my fridge and get the hot sauce from the top left-hand corner. Now, as I was saying, what's different? Thank you, Connor. You're the best. Don't let anyone tell you different. What's different? I'm sorry, what was that, Jezreel? I know the output, don't I? What is the function I'm dealing with? I'm dealing with g of x, yes? The function is, that's a highlighter, you idiot, g of x equals negative 2/3 x plus 1, yes? Now look closely. G6, gx. As Jazreet says, I know the output this time. So do I know an x value? No. That 7 has to go there. So what do I have really? 7 equals negative 2/3 x plus 1. And what must I do if I want to fill in this table? Because now I have not a 4, you moron. I have a 7, and I'm missing the x. So what do I need to do to this guy in order to be able to find this guy? While I take a bite of my lazy Benny, which is good because I forgot to eat breakfast this morning. Lovely. No one in the room can tell me what to do with that thing highlighted in green. You have to isolate x, just like you have to do every time you see a variable. How will I isolate x? Apparently an algebra lesson is in order. How will I isolate x? I'm not going to lie. I'm a little hurt that Carlin Connor, Daniel Kaur, Ali Harrington, and that's it, aren't saying anything. Because I know I taught them algebra. You're going to move the 2 and the 3 first? You're going to move the 1 first. How do I move the 1? You could subtract it. If I do something to the right, what do I do to the left? Same thing. So what do I have now? I have 6 equals negative 2/3 x. Now what do I got to get rid of? 2/3. So I can either divide both sides by 2/3 or I can do it in 2 steps, yes? How do I get rid of that 3 first? What math do I see there? Division. So what math do I do to get rid of division? Multiply by what? 3. So what happens to the 3's? They're gone. And I've got now negative 2x equals what? 18. Now what? Divide by y.
Because you're multiplying by 2.
So now what does x equal? Negative 9. So what can I write right there? Negative 9. Does that make sense? As I go further down the negative scale, my y's are getting bigger, yes? So if I go out here to negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, is that on my line? Indeed it is. Is everybody cool? So, I now wish for you to find, please notice, what do I ask you to do in number 5? What do I know here? Do I know an x value or a y value? What about there? What about there? Y. So let's do this. I need the m of 7. It's not the m of x anymore, it's the m of 7. So what goes in for that x? 7 plus 2. Right? How do I do 4/3 times 7? What's 7 really? 4 times 7? That's 9 and 1/3 plus 2. What's 9 and 1/3 plus 2? What's 9 plus 2? 11. So what's 9 and 1/3 plus 2? 11 and 1/3. So what is my x and y for that value? 7, 11 and 1/3. That's the first point on my graph, right? What's the next point on my graph? I don't want the m of 7. What do I want? M of 1. So it's 4/3 times what? 1 plus 2. 4/3 plus 2, which is 1 and 1/3 plus 2, which is 3 and 1/3. What's the ordered pair for that one? 1 and 3 1/3. What's different in the third one? M of x equals 5. So I have 5 equals what? 4/3 x plus 2. And now what's my job in 5 that is different? Isolate x. How do I get rid of the plus 2? Subtract 2. How do I get rid of divide by 3? Multiply by 3. What happens to those 3's? Cancel. 4x equals 9. What's the last step? X equals 9/4. So what is my ordered pair out here? 9/4, 5. Can everybody grasp this? Please notice that I've put in the fractions to get some double duty out of these, right? He said duty. Do you know what I mean? You have to practice your algebra, but you also got to remember how to deal with fractions. That's the only reason I'm putting them there. Everybody cool? All right. You guys try number 6. Go. I'm just going to screen off. You guys try number 6. Mm-hmm. I'm going to wait a moment now while you guys finish that off. You can talk to your neighbor if you need to. You look at all your... There is the answers. All of you should be comfortable with this. Even if you didn't bother to write it down, you should be able to figure out what is going on from here. And it's on the video. All you're doing is substituting in what you know and then doing grade 8 algebra, right? If you don't remember algebra, when are you going to learn it? Or how are you going to learn it? What is your job now if you cannot do the algebra part of this? I'll pretend all of you are flooding me with answers. In my mind, I'm seeing 30 hands and I'm able to pick on one of them. You could practice, but I could practice Sanskrit, but I can't read it, so it won't matter. What must you do if you cannot figure out this algebra? Talk to somebody who knows algebra. If you don't like me, don't come to me. Go to somebody else who knows algebra. If you don't like anybody, go to your best friend, the internet, and ask how to do algebra. Because one of the 13 million pages there will speak to you. Okay? I'm going to go off this page now. If you don't have it written down, you'll need to go back and get it from the video. Now this next one's a little bit of a hassle, because on my screen it's in color, but on your screen it's not. So I got 2 lines there, but I did label them for you. Okay? So for me, the blue one is g of x and the black one is f of x. For you guys, the curvy one is f of x and the straight line is g of x. Okay? All right. Now, I think, did yours print properly? Do you have the labels? Okay. So, in this first one, f of -3. First question to ask yourself, what am I looking at? The curved line or the straight line? They've already been talked to about the pep rally.
No, it's school clothing.
Come in.
All right.
If only I could teach. Which am I looking at? The curvy one or the straight one when I see the f of -3? The curvy one. Excellent. Is that an x input value or a y output value? That is an x input value, isn't it? Where on this picture do I find x equals negative 3? Where do I find x of negative, where x is negative 3? I go out to negative 3 on the x-axis, yes? So my input is negative 3. Do I have an output yet? Where is the output? It's right there, correct? What is it? Negative 2. So the f of negative 3, x is negative 3, what's the output? Negative 2. So the ordered pair is negative 3, negative 2. Does everybody understand? And I'm going to do all these in a different color to help you out. G of 0, what am I looking at? Straight line or the curve? Straight line. Is it an x value or a y value that I've been given? X value. X value of what? So I go to where x is 0, and then I find my output. Where is it? Up there, and it is 2. So what's my ordered pair? 0, 2. Thank you. Thank you. Double. What service? I feel like I should give her a tip. I'm going to tip her 30% of my bill. The bill was 0. I got her. Yeah. If she works really hard, I'll double the tip. All right. Seriously, though, folks. This next one. Am I looking at the curve or the straight line? The curved line. Do I have an x value or a y value? X value of what? Negative 2. So on the curve, I go out to negative 2, and then what? I find where it hits the line. Way down there, which is what? So my ordered pair is negative 2, negative 3. Is everybody cool with the first 3? Okay, what's different in D? I'm going to erase everything I've got because it's going to be getting confusing. What do I have now? I have an output. So that is an output. So it's on what axis? So it's on the y-axis. And what is that output? 1. So I go to the y-axis and I find 1. And I'm on the curvy line, yes? So it's there. And where else? Does everybody see? Because my output is 1 in 2 different places. So what is my x when my output is 1? How many of them are there? 2. And what are they? 0 and negative 4. Does everybody see how that one works? Okay. What about E? G of x is 3. So where do I go? The straight line. And do I go, is that a y or an x value? That's on the y-axis. To where? I go up to 3, and now I got to find my x. Where is it? Right there. And what is it? Negative 1. Everybody cool? All right. So now, even though your graph is probably getting a little busy, you should still be able to do the other 2. You guys go. Tell me what they are. Then we're only going to do one more thing, and then I'm shutting up. X or Y value? X, so I go out to 4. Do I want the straight line or the curve? Straight line, so I find the Y value that matches up with 4, and it is -2. F of X is -2. Where do I go? To the Y value. Now I need some X values. How many of them are there? 2. There's one there and one there. What are they? -3 and -1. Is everybody cool? Okay, now, that's everything you need to know. But I want to show you one more thing. F of X equals X plus 3. Everybody cool? Everybody cool? Okay. G of X equals X minus 5. Everybody still cool? Okay. See if you can figure out the F of the G of 8. What? And when you're done trying to figure that out, you're going to go on to the next page, and that's your work. I'm going to let you try to figure that out for a while, then I'm going to show you how to do it. That's the first thing you're doing on your own. Talk to your neighbor if you need to. You guys are smart. Where would you start with this question? The F or the G? The G, because it's in the middle. Okay, how do you do the G of 8? I don't need the G of X, I need the G of 8. So what do? Replace X with 8. 8 minus 5. What is the G of 8? 3. If the G of 8 equals 3, what can I put right there? 3. So now all of a sudden I'm looking not for the F of the G of 8, I'm looking for the F of 3. And what's that? 3 plus 3, which is 6. Does everybody understand that? That's the hardest thing I can do with function notation. The hardest thing. Please notice the only difference is instead of Y, what do we write? F of X, G of X, H of X, Q of X, P of X, whatever. Does everyone understand? What if I wanted the F of lightning bolt? What would you write? Lightning bolt plus 3. Everybody get it? What if I wanted the G of happy face? What would I write? Happy face minus 5. I can't make it simpler. Everybody with me? Okay, your job is page 319. Now please notice 319 looks gigantic, but again, it's because of all the pictures. Okay, the answers are there. This is the last thing for this unit. So tonight, you're going to work on 319 a little bit. Okay, tomorrow when you get in here, I'm going to want your versions of this, right? Make sure they're done. You're not going to give them to me yet because I'm going to put up the rubrics. So you're going to mark them yourself tomorrow. We're going to go over 319, right? Because you're not going to see this notation much anymore. You're going to see it as a function for a long time. After grade 10, I'm still going to use this because I'm still teaching you with it. But after grade 10, we go to function notation mostly. So we're going to spend some time going over these pages. We're going to go over this. You're going to mark your own, right? Based on what I show you. And then tomorrow night for homework, I'm going to assign you the review from this unit. We'll mark it Thursday. And depending on how things go, we might test Friday. We might test after. Okay? Everybody cool? All right.